So we're going to find energy, W, okay? WC, WL. Since this is the under DC condition, what do we need to do with these inductors? Short circuit, capacitors, open circuit. Great. So that's what we want to do first. So I'm going to just draw one more time. And this is VC1 plus minus. And this is IL1. This is plus minus VC2. And here IL2. This is 3. This is 3. And this is 6. And this is 6. So I label as a VC1, VC2 as an open circuit for the place. Replace with these capacitors. And then IL1, IL2, we label that where that the inductors were. So our objective is to find IL1, IL2, VC1, and VC2. What do we do? Any suggestions? Okay, combine 3 and 6. We can do that. However, if we do, we're gonna lose this information, right? If you combine this still, we can say IL2. However, once you combine it, we cannot find this VC2. And you can combine it and then find the some other terms and put it back. That's fine. But for this exercise, I want to just keep it as it is and then use some technique to find it. That's correct. IL1, well, basically KCL right here. So we can do good starting point. I'm going to let this guy as a A. And then when we do KCL at node A, now we have IL1 plus entering 3 equals leaving IL2. That's one equation. Good? Okay, good starting point. What else? Mesh? Okay. Okay. Super mesh? Okay. Let's do that. So super mesh. So we have here, I'm going to call it mesh 1. This mesh 1 is actually IL1. And then second one is going to be here, which is IL2. And then we're going to do super mesh. So our super mesh is going to go around this. So mesh with super mesh, -9 plus 6 IL1 plus 3 IL2 plus 6 IL2 equals 0. So now we have 6 IL1 plus 9 IL2. So 9 equals to 9. And we already did the KCL, include this middle current. So that is IL1 minus IL2 equals to -3. 3 equations and 3 unknowns. Calculator. Okay. So we have that. VC2. That's the easy one, right? The voltage across here is the same as voltage across here. Therefore, VC2 equals to 6 times IL2, which is 6 times 9 over 5, which is 54 over 5 volts. Now to find the VC1, we're going to calculate the voltage across here, 6 ohm first. That is, I'm going to just call it as plus minus Vx. We need to find Vx equals 6 times IL1, 6 times IL1, -6 over 5. Therefore, -36 over 5 volt. So actual polarity is the opposite because the current I of IL1 is going opposite direction, negative. And then we do KVL around here. Then -9 plus Vx plus VC1 equals to 0. From here, -9 minus Vx 36 over 5 plus Vc1 equals to 0. Negative 45 over 5. So from here, Vc1 equals to what? 81 over 5. So now we have Vc2, Vc1, IL, I2. So now Wc1 equals 1 over 2 times. What's the C1? 20 micro. 20 times 10 to the negative 6. And then Vc1, 81 over 5 square. And then Wc2 of t equals 1 over 2. 50 times 10 to the negative 6. And then Vc2, 54 over 5 square. These are the joules. And then WL1 of t equals to 1 over 2. L1, 2 milli, 2 times 10 to the negative 3. And then IL1, negative 6 over 5 square joule. WL2 of t equals to 1 over 2. L2, 4 times 10 to the negative 3. And then IL2, 9 over 5 square joule. Use your calculator, find the values, that's it. Just anybody who got the WC1, say it.
About 2.6 times
10 to the negative 3 joule. Okay. WC2, right. So when I have the answer. This is 2.9, 10 to the negative 3 joule, and WL1, 1.4 millijoule, and WL2, 6.5